All right, so today in Algebra 1, we're going over Chapter 3, Lesson 1, writing equations. So to start us off, we're going to talk about what we're going to learn in this lesson. First thing we're going to learn is we're going to learn how to translate verbal sentences into equations. So going from words into algebraic symbols. And on the flip side of that, we're also going to learn how to go from equations, right, algebraic symbols into verbal sentences, right, into words, letters. So going back and forth between verbal sentences and equations, and then from equations back to verbal sentences. So some of the vocabulary that we're going to see in this lesson, first thing we're going to talk about is a 4-step problem-solving plan. We're going to talk about defining a variable, and we're also going to be talking about a formula. So all these things are vocabulary that will be defined and talked about in the lesson. So how are equations used to describe heights? So in this scenario, we're going to say the Statue of Liberty sits on a pedestal that is 154 feet high. The height of the pedestal and the statue is 305 feet. If S represents the height of the statue, then the following equation represents the situation. So first, let's take a look at a picture here. So here I have a 154-foot pedestal, like it says in the problem, and I have the height of the statue S, and it told me that the pedestal and the height of the statue was 305 feet. So if I were going to write an equation, it would look something like this. 154 plus S equals 305. So I took the height of the pedestal plus S, the height of the statue, and it equaled 305. Now, some people might have viewed this a little bit differently. So maybe when you were looking at it, you maybe said, well, I wrote that equation a little differently. Maybe when you were looking at it, your equation was more like 305 minus 154 equals S. Or maybe you looked at it a little differently. You said, well, I just took the total height, 305, and I subtracted the height of the statue, and S equals 154, right? So I don't really like that S there. I'm going to change that real quick. Mr. S, you can go away. Let's go ahead and we'll do the S one more time. That was just bugging me there. Okay, so 305 minus S equals 154. So if I look at that, I can see that the equation can be written in multiple different ways, right? This equation can be set up in multiple different formats, but they all represent the same situation. So let's go ahead and we will okay. So we're going to go ahead and take a look at, well, what about writing equations, right? So what are some strategies and some methods? So when writing equations, we want to use variables to represent unspecified numbers or measures referred to in a sentence or a problem. So basically, anytime we have an unknown, something that's not stated in the problem, we're going to use a variable for it. And then we're going to write the verbal expressions as algebraic expressions. And so some verbal expressions that suggest the equal sign are ones that follow. So for example, is would typically represent an equal sign in a problem. Equals, that's probably more straightforward, is equal to, is the same as, is as much as, and is identical to. All of these terms would be representative of an equal sign in an equation. So when we're reading through these expressions, we want to look for those key phrases that would signify an equal sign. So let's go ahead and let's take a look at some examples. So we're going to be translating each sentence into an equation. So if I look at A, it says 5 times the number A is equal to 3 times the sum of B and C. So there are a couple different phrases that we want to kind of look at. So I'm going to group them together. I'm going to say, okay, well, I have 5 times A is equal to, there's that key phrase, I know that's where my equal sign is going to go, 3 times the sum of b and c. So if you remember, sum is addition, right? That's an addition problem there. So I'm going to do the sum of b and c. So I know b and c need to be added together. So if I start to write my stuff out, I have 5 times a is equal to 3 times the sum of b and c. So this is a place where I want to use grouping with parentheses to make sure that those get added together before anything else happens, like getting multiplied by 3. And since we're going to be working with variables, using this as our multiplication symbol can get a little bit confusing. So what we're going to do is we're going to write it in a more simplified way. We're just going to write it as 5a equals 3 quantity b plus c. Okay, so we don't really need that x there that we would in the past have used for multiplication. We can just put 5a. That represents 5 multiplied by a, or 5 times a. Same thing here, right? We don't need that multiplication symbol, so 3 times the quantity of b plus c. Let's look at the second one. 9 times y subtracted from 95 equals 37. So I'm going to rewrite this a little bit just because I know in subtraction, order does matter. So if I'm subtracting from 95, it's going to be 95 minus that quantity. So I'm going to write it as 95 less 9 times y equals 37. Okay, so I'm going to be taking away 9 times y from 95. So the 95 needs to come first. So I'm going to go ahead and write it as 95 minus 9y equals 37. And again, just to write it a little bit more succinctly, that would be the equation 95. Now all right, 95 minus 9y equals 37. All right, so let's look at, the next step is examining that 4-step problem solving plan. So using this can help us solve lots of word problems. And I've heard from students many a times that word problems are the most difficult thing and I don't know how to do them. So this is going to give us some kind of more straightforward strategy for dealing with problems like that. So a couple things to keep in mind, right? So 4 steps. So the first step is just going to be exploring the problem. Second step is planning the solution. Step 3 is solving the problem. And step 4 is examining the solution. So a lot of times people want to just go straight to the answer, and sometimes it takes a few more steps. So that's what we're going to take a look at. So step 1, exploring the problem. What does that mean? Well, to solve a verbal problem, we need to first read the problem carefully and explore what the problem is about by identifying what information is given and identifying what we're actually being asked to find. What is this question actually asking me to do? After we've explored the problem, we're going to go ahead and we're going to plan out our solution. All right, we're going to come up with a strategy to solve. And one of these strategies that we're going to use is by writing an equation. If we can write an equation to the situation or the problem, that's going to help us kind of plan for a solution. And a lot of times when we're looking for something, it's an unknown value, right? And so we're going to define that unknown value with a variable, right? A variable represents something that is unknown. Okay, and then step 3, solving the problem. If you have an equation and a variable, you can go ahead and start going through the process of finding the answer. And then step 4 is going to say examine the solution, right? Once you've solved the problem, right, and you use your strategy and solve the problem, you should check to see if your answer actually makes sense, right? Does it make sense in the context of the problem? Is it too big? Is it too small? Does it fit with the information that was given? If it asked me to find how many puppies there are and I got, $34, that doesn't really make a whole lot of sense with the information that was given. So really making sure that you're checking your solution, that it actually makes sense in the context of the problem. Okay, so how do we use this 4-step plan? So let's use this in a problem. So here I go. The first ice cream plant was established in 1851 by Jacob Fussell. Today, 2 million gallons of ice cream are produced in the United States each day. That sounds like a lot of ice cream. So we're going to use that information. And it says, in how many days can 40 million gallons of ice cream be produced in the US? So let's start with step one, exploring the problem. Okay, so we noticed that 2 million gallons of ice cream, right? That information was given over here, was produced in the United States each day. And we want to know how many days it's going to take to produce 40 million gallons of ice cream. So I'm going to go ahead and make a plan, right? So if I'm going to plan this out, I know that can write an equation, right, using what I'm given, with the information I'm given, and I can set up a variable with the unknown, right? So the unknown, the information I don't know, is how many days. So I'm going to go ahead and let D represent the number of days needed to produce the ice cream. So D is the unknown, representing the number of days. And then I'm going to go ahead and write my equation. So I know that 2 million gallons are produced times the number of days should equal 40 million gallons, because that's what I'm trying to figure out, right? So when I write my equation, I'm going to do 2 million times D equals 40 million. So when I solve, right, I can go ahead and look at this equation. So I have 2 million times D equals 40 million. A lot of people can probably solve this equation in their head, right? If you use a little bit of mental math there, you're like, oh, I'll do 40 million divided by 2 million, and that's going to get me 20, right? So I'm like, oh, okay, well, that means that it took 20 days of the ice cream plant producing 2 million gallons of ice cream. It's going to take 20 days to produce 40 million gallons, right? So not too bad. Now that we have our answer, we have to examine the answer, right? What does it actually mean, right? What does it actually mean? And the one way we can examine is to see if it actually makes sense is the ice cream produced in one day. I could work it backwards, right? If I did 2 million times 20, right, working the problem backwards, that's going to tell me that it gives me 40 million. So it actually does work out if I work the problem backwards, right? That is one method of checking your answer to see if it actually makes sense. You can work the problem forward, then you can work it backwards. The next step is a formula. A formula, right, that's one of our vocabulary words, is an equation that states a rule for the relationship between certain quantities. Sometimes you can develop a formula by making a model. So let's go ahead and look at an example where we do that. So write in a formula. It says translate each sentence into a formula. The perimeter of a rectangle equals 2 times the length plus 2 times the width. So I'm sure you've done this before. Here's a rectangle. Here's the length, here's the width. And when we look at this and we wanted to find the perimeter, well, perimeter is the outside. So if we were to add up this side plus this side plus this side plus this side, if this is length L, this is also length L. And if this is W, then this is also W. So if I add up all 4 of these sides, I'm going to add up 2 lengths and 2 widths, right? So if I were to go ahead and write this out in words, the perimeter equals 2 times the length plus 2 times the width, right? So my variables are L and W, right? And P, I can say, is my perimeter. So when I write this formula out, my perimeter P, right, equals 2 times the length, right, 2 times L, plus 2 times the width, right, 2 times W. And so when I write out my formula, it's going to look like this. So my final, very succinct answer is going to look like that. The formula for the perimeter of the rectangle is P equals 2L plus 2W. So let's translate each equation into a sentence. So in this example, we're given 2 different equations, and we're asked to translate each one of them into a verbal sentence. So see here, if I were just to read it, right? 3m plus 5 equals 14, right? 3m plus 5 equals 14, right? Here are the words. 3 times m plus 5 equals 14. These, I feel, are a little bit more straightforward. And then here I have w plus y equals y squared. So in words, the sum, right? Sum is going to mean addition, right? The sum of w and v equals the square of y. okay? Y squared is going to be the square of y. So now, last example here is how would you use this to help you write a problem? So now we're going to go backwards. Now we're going to take a look at this problem here. And it says, write a problem based on the given information. Raphael's age is equal to A. Tierra's age is equal to A plus 5. And then we have this third equation over here that says A plus 2 times quantity A plus 5 equals 46. So we're going to write a problem based on this given information. So one thing I know is that Raphael's age is A. Well, there's an A right there. And Tierra's age is A plus 5. Well, there's A plus 5 right there. But it's being multiplied by 2, right? So I know that if I took Raphael's age plus 2 times or twice Tierra's age, that's going to equal 46. So an example of a problem that I could write is, you know that A represents Raphael's age, and A plus 5 represents Tierra's age. The equation adds A plus twice A plus 5 to get 46. So Tierra is 5 years older than Raphael, right? Because it's A plus 5. The sum of Raphael's age and twice Tierra's age equals 46. How old is Raphael, right? And so this lends us into a problem that would be using this information here in the context of this problem. All right. Thank you guys for watching. That is an intro lesson on how to write equations from verbal expressions and how to write verbal expressions or from equations. All right. Thank you.